Hello everyone, how's everyone doing tonight? Okay, we're continuing with Git. I will have a little bit less time today than usual. So, yep, let's back to it immediately. And we're gonna continue with our Pro Git book. All right, let me just make sure that I have everything in place. Alrighty. There we go. So Git SCM and our Pro Git book. And we went all over through here, and today is finally Git branching. Finally, we're starting to get to the really useful part of Git. I really don't know why the book was putting it off so long. Go into like more advanced features and whatnot first. We'll see. And we just verify that everything looks okay. I think everything looks okay. I think we're good. All right. So there we go. Git branching, branches in a nutshell. Nearly every VCS has some form of branching support. Branching means you diverge from the main line of development and continue to do work without messing with that main line. In many VCS tools, this is a somewhat expensive process, often requiring you to create a new copy of your source code directory, which can take a long time for large projects. Some people refer to Git's branching model as its killer feature, and it certainly sets Git apart in the VCS community. Why is it so special? The way Git branches is incredibly lightweight, making branching operations nearly instantaneous, and switching back and forth between branches generally just as fast. Unlike many other VCSs, Git encourages workflows that branch and merge often, even multiple times in a day. Understanding and mastering this feature gives you a powerful and unique tool. You can entirely change the tool and can entirely change the way you develop. Absolutely. Branching is like, free operation. So branching in a nutshell. To really understand the way Git does branching, we need to take a step back and examine how Git stores data. As you may remember from what is Git, Git doesn't store data as a series of change sets or differences, but instead as a series of snapshots. When you make a commit, Git stores a commit object that contains a pointer to the snapshot of the content you staged. This object also contains the author's name and email address. So when you make a commit, Git stores a commit object that contains a pointer to the snapshot of the content you staged. So the snapshot has only the content that we staged. It doesn't have a content of everything, right? This way, commits are small. This object also contains the author's name and email address, the message that you typed, and pointers to the commit or commits that directly came before this commit. Its parent or parents. 0 parents for the initial commit, 1 parent for a normal commit, and multiple parents for commit that results from a merge of 2 or more branches. Oh, you can merge more than one branch into the other. You can just merge multiples. That's a new concept for me. To visualize this, let's assume that you have a directory containing 3 files, and you stage them all and commit. Staging the files computes the checksum for each one. The SHA-1 hash we mentioned is what is Git. It stores that version of the file in the Git repository. Git refers to them as blobs and adds that checksum to the staging area. Okay, so git add readme, test rb, license, whatever, git commit, and initial commit. When you create the commit by running git commit, Git checksums each subdirectory. In this case, just the root project directory, and stores them as a tree object in the Git repository. Git then creates a commit object that has the metadata and a pointer to the root project tree so it can recreate that snapshot when needed. So it seems like a checksum checksums each subdirectory. Does it mean that it treats directories different than files, or does it mean that it just makes a checksum for entire contents of a subdirectory? Therefore, it doesn't need to like store any additional data about it. It's just, hey, this subdirectory exists, that's its SHA. If contents change, the SHA will change, therefore, whatever. Interesting. I guess that will be in the further chapters when we go in a little bit more detail. So your Git repository now contains 5 objects, 3 blobs, each representing the contents of one of the 3 files, 1 tree that lists the contents of the directory and specifies which file names are stored as which blobs, and 1 commit with the pointer to that root tree and all the commit metadata. Okay, so let's see. So we have this thing here, the commit. Okay, this is a picture. So we have the commit, which is kind of hard to read with this dark mode here. But okay, we have some checksum and commit size, tree, author, committer. So wait, commit size. Tree is this, author Scott, committer. All right, the initial commit of my project, right? So this is that. And this points at the tree, which this tree says that, hey, there's this blob of readme, there's the blob of license, and there's a blob, and it specifies what are the checksums for them. And there it actually points at them, and each blob has some idea of the contents, right? Okay. So figure 9, a commit edits tree. If you make some changes and commit again, the next commit stores a pointer to the commit that came immediately before it. So I guess we had the first snapshot, right? The initial one. Then we create another commit. It says, hey, it's a different tree. Excuse me. It says that the parent is this commit that came earlier and has some description. And it points to the snapshot B. So I guess that's the new tree, right? All like the tree that defines what the things are. So that's snapshot B. And then we have snapshot C, which is yet another one. Parent is this one and whatnot. Okay. So nothing crazy, but every time the tree changes. So something tells me that for now, this tree is basically the snapshot, which defines what is in the tree and like where to point. Like tree points to blob with this SHA, this file of this SHA, that file of that SHA. So if in this comment here, we maybe change only readme, something tells me that the tree would have just a readme with new changed blob that points at the new version, as at the new blob of that tree, but the other ones will be pointing at existing blobs. So we kind of reuse them. We only point to them through SHA-1, and this way we don't store any extra data. And also here it was mentioned that for each directory, it creates this tree object, like each subdirectory. So something tells me that if you had some subdirectories with maybe hundreds of other files, we calculate 1 SHA for just that one directory. Therefore, if none of those 1,000 files changed during the commit, we're not listing 1,000 files in this tree. We just have one link to one blob, and that's it. And we can keep reusing that. So I guess that's what's happening. A branch in Git is simply a lightweight movable pointer to one of these commits. The default branch name in Git is master, nowadays main. As you start making commits, I guess, or maybe I'm just due to the fact that I'm always dealing with GitHub. I know it always seems to be set to main, so I don't know. As you start making commits, you're given a master branch that points to the last commit you made. Every time you commit, the master branch pointer moves forward automatically. So we had the first commit, right? Snapshot A, then snapshot B, snapshot C. And our Okay, so the master branch in Git is not special branch. It's exactly like any other branch. The only reason nearly every repository has one is the git init command creates it by default and most people don't bother to change it. Okay, so a branch is simply a lightweight movable pointer to one of these commits. Okay, so that's all branch is. Branch is a pointer, nothing else. The default branch name in Git is master. So therefore the master is pointing also to the latest commit, right? Because if we create a branch, we just create a pointer. Points at this one and that's it. Okay. And then we have the idea of the head. And as far as I know so far, because this hasn't been mentioned yet, head is basically what we have currently checked out. Or maybe I'm wrong. I don't know. Create a new branch. So what happens when you create a new branch? Well, doing so creates a new pointer for you to move around. Let's say you want to create a new branch called testing. You do this with the git branch command. Git branch testing, okay? This creates a new pointer to the same commit you're currently on. All right, so we were in the latest commit that we committed, right? And we do git branch testing and we just get a new pointer. Okay, simple. How does Git know what branch you're currently on? It keeps a special pointer called head. Know that this is a lot different than the concept of head and other VCSs you may be used to, such as Subversion or CVS. In Git, this is a pointer to the local branch you're currently on. Okay, so it is just what we're currently on. In this case, you're still on master. The git branch command only created a new branch. It didn't switch to that branch. Okay, so our head is still pointing to the master. So you can easily see this by running simple git log command that shows you where the branch pointers are pointing. This option is called decorate. Oh, so git log one line decorate. And we have this command which says, hey, head points at master. And then we also have testing branch here. Blah, blah, blah. You can see master and testing branches that are right there next to the commit hash. Okay, so switching branches. So I want to start trying it out. So maybe we're gonna go to temp, it was git test one, right? So we've had those few files. If we're gonna do git log one line, not lig log, git log one line. I mean, one line already shows me everything here, right? So we have the, we start with initial project version, we define new project and git ignore. We still have that tag that we created during the exercise. Adding a file, and then recent commit was whatever, cleanup, when we cleaned up some stuff. And we can see that the head is pointing to the main branch. And we also have the tag this and the tag that, all right? So if I would do git branch testing, okay, and run again log one line, which for some reason decorates automatically, we can see that head is pointing to main. We have the tag this, we have tag that, and we have testing. Okay, so we see both tags and testing. And tags have this prefix, while branches don't have any prefixes. All right, makes sense. So to switch to an existing branch, you run the git checkout command. Let's switch to the new testing branch, git checkout testing. And I think that's the old way to do it. Git checkout testing. Switch to branch testing. So we run git log outline, and now head is pointing at testing. Okay, so finally I understand what head is and what it means. But I know that you can have detached head, you can do some other weird stuff. So I guess you can do fancy stuff with that. Okay, so this moves head to point to the testing branch, right? The head is pointing at testing branch, which is just a pointer to a commit, and that's it. So figure 14 head points to the current branch. What is the significance of that? Well, let's do another commit. So we're gonna change something, right? So let's do make a change. We're going to maybe change our package JSON, right? We're gonna say that it's version 2, and I don't know, license, I don't know, MIT, right? And we do write all. We can quit all as well. So in our git status, we have, okay, we changed this, right? So git commit all, because we don't have any other changes, and we're gonna make a message bumped version, okay? And we're gonna not say that we changed the license, all right? That's secret. Bam. One file change to insertions to deletions. To insertions, what? I guess I changed something more. What the hell? Don't know where two insertions and two deletions come from. I guess maybe because I changed the lines, so each two lines were deleted, 2 lines added. Yeah, okay. So git status, we don't have anything. Git log 1 line. Okay. So look at that. So our head is on testing. Bump version. So this shows that bump version doesn't have the main. So yeah, because this is not on the main branch, this is only on the testing branch. And this is where the head is, while the previous one still shows the tags, but also shows the main branch. So I guess that's where the main branch is pointing at, as that's the latest whatever main branch is supposed to be. Okay, because a branch is literally just a pointer. It's not like you have lots of commits and they all belong to that branch. Really, only one commit belongs to the branch, really, because it's just a pointer. The fact that we have an idea that, you know, these commits belong to the branch is because they're accessible only from within it or something. It's like a consequence of the fact that a branch points only at a single thing. Okay. All right, and we have this situation here where we had this master and testing pointer here. We create a new commit, and now testing is pointing at that new commit. So this is interesting because now your testing branch has moved forward, but your master branch still points to the commit you were on when you ran git checkout to switch branches. Let's switch back to the master branch. So we could do git checkout main. Switch to branch main. I'm gonna run our log 1 line, and look at that. We don't even have the commit that we just created. So git log doesn't show all the branches all the time. If you were to run git log right now, you might wonder where the testing branch you just created went, as it would not appear in the output. Exactly, it's nowhere to be found. The branch hasn't disappeared. Git just doesn't know that you're interested in that branch, and it's trying to show you what it thinks you're interested in. In other words, by default, git log will only show commit history below the branch you've checked out. Okay. To show commit history for the desired branch, you have to explicitly specify git log testing. To show all of the branches to show all of the branches, add all to your git log command. So let's see, git log testing, 1 line. There we go. We're back to where we were before. What if we're gonna do, instead of testing, we're gonna do all 1 line. There we go. We've got everything. We actually got extra more. Yeah, I remember we created a branch temporarily for testing. Oh, it was through some other command that they were showing out before explaining branches, that there's an alternate reality, whatever. And we split the timelines, and that's it. Okay, and that was actually entirely commit. Huh. What was it? Git show, and I could do D65B51A. Will that work? Yeah, look at that. That was the README. And we just added, yay, so excited. Okay, and that was, lost. It just exists somewhere there, huh? So we did that. We see this fact here that we basically, our head moves from testing here to the master here. It just points at master, which points at this, and it's aware only from what was before, not really what is after it. So the command did two things. It moved the head pointer, that command, which is git checkout master. The command did two things. It moved the head pointer back to point at the master branch, and it reverted the files in your working directory back to the snapshot that master points to. Exactly. So we're gonna do a new vim, go to the package JSON. We can see that we have license still ISC instead of MIT, and version is 001. So that's awesome. Yeah. This also means the changes you make from this point forward will diverge from an older version of the project. It essentially rewinds the work you've done in your testing branch so you can go in a different direction. So switching branches changes files you're working in your working directory. Exactly. It's important to know that when you switch branches in Git, files in your working directory will change. If you switch to an older branch, your working directory will be reverted to look like it did the last time you committed on that branch. If Git cannot do it cleanly, it will not let you switch at all. Yeah, so another thing is that, let's say I'm on main now, right? I'm on main. If I'm going to, let's say, go and create a file, wolala, right? And just do a bunch of whatever, okay? Let's do writing quit. Git status. Okay, we don't even have it staged, it just exists. So if I'm gonna do git checkout testing, right, it switched. It didn't stop us. Git status, we still have that wololo in our working directory. It's still not tracked, so it didn't have to touch it. What if I'm going to stage it? What's gonna happen if I'm gonna do git add wololo? Okay, it's staged as added. So what's going to happen if I'm gonna go back to main? Check out main. It switched, and our git status still has wololo in staging as added. So the way I always understood it is that you can have stuff in staging, no problem, as long as it doesn't modify any files that change between the two branches that you were doing something with. So let's say, how would I revert it now? Git restore staged wolala, right? And that did that, and then we do. Now I can just remove the wolala because it doesn't exist anymore, and we're nice and clean. So let's say that instead of doing all this stuff, we have those files. We know that right now we're on main branch, and on our what do you call it? On our testing branch, we already changed the package.json. So let's try it. So let's say I'm gonna here on main going to change the package.json. Okay, and we're gonna change maybe not the version, maybe not the license, maybe we're gonna add an author. Okay, there we go. We're gonna save it and git status. We have it here. Maybe we're gonna do add package JSON, right? So we have it even staged. The moment I will try to go to the testing branch, it should tell me that, hey, there's a conflict because package probably already changed on the other branch. So let's see, git checkout testing. Error, your local changes to the following files would be overwritten by checkout package JSON. Please commit your changes or stash them before you switch branches. There we go. So that's the whole idea, that because package.json changed on the branch that we're moving to, it will just say, hey, whatever you have here would be lost. All right. So we do git restore staged package JSON, right? So it's not staged. We just have it modified in working directory. What if we'll try to switch now? Still, it just detects that in our working directory we have different version. So I guess we need to do git restore package JSON, right? And now we deleted all our changes, so we should be able to switch to testing and no problem. And the same would be if we go and change something like package JSON here now, and we'll try to go back to main, and because there were differences, it will try to restore the file, and it's gonna be like, oops, no. But what if we have a file that hasn't changed between the two versions, but already is in Git? Let's say neovim readme. And I'm just gonna add to the tech stack that our tech stack involves, I don't know, a little bit of brain power. Okay. That's part of the stack. We need to have a little bit of that. All right. So git status, we see that we modified readme. Let's do git checkout main. And we were able to switch. All right. So git didn't stop us because that file didn't change between those two branches. Therefore, nothing would be overridden. We still have it that, hey, we made a modification. So, okay, good. So let's restore readme and we're good to go and continue. Okay, so I think it's good to remember that the conflicts between switching between branches is only for the files that were modified between the branches and therefore would override your changes. Everything else would just go on. So often when switching between branches, if you're like adding new functionality, oftentimes you don't even need to stash anything. You don't need to try to save it, commit or whatnot. You can just kind of transfer around, which is nice. Okay, so we did all that. Let's make a few changes and commit again. So vim test rb, git commit, make other changes. Now your project history has diverged. Oh, so we're on the main branch. We're just gonna git. Oh wait. Let's do neovim readme. Sure. Or what did they change in the other one? Because I wonder if it wants to. Yeah, in one make a change was test RB, and on the testing we modified test RB, and on this one we're also modifying that. So let's do neovim package JSON. So in both situations we're modifying the file, and I'm gonna add the author. Okay, and git commit all, and this will be added author. All right, bam. So git log 19. We see that, okay, after a cleanup, we have our new commit here. And if we're gonna add all, what's gonna happen now? So besides the normal stuff and ignoring the alternate reality, we have our testing where we bumped the version, and we have our head on main branch where we added the author. So both commits coexist. What it will look like if we're gonna do, what was it? Graph? Look at that. Initially, when we created alternate reality from that tag, it diverged, right? We have this split here. And then we continued still from our main branch, continued, and from cleanup, we have two versions. First, we created the one in the testing branch, and now we created one in author. We have this divergence here. So I guess it's been displayed relatively clearly. Yeah, so we did another change. Now your project history has diverged. See the divergence history. You created and switched to a branch, did some work on it, and then switched back to your main branch and did other work. Both of those changes are isolated in separate branches. You can switch back and forth between the branches and merge them together when you're ready. And you did all that with simple branch checkout and commit commands, right? So that was relatively simple. And we can see this kind of graph visualization that we had our commits and now our testing commit. Testing still points at that because that's the last commit that was for that branch. But our master or whatever main branch points at, again, not here anymore, at the new branch. So we have this split. They are not connected anymore. You can also see this with the git log command. If you run git log one line decorate graph all, it will print out the history of your commits, showing where your branch pointers are and how your history has diverged. What if I would run something like lazy git in this directory? I guess I just run lazy git and that's it. Okay, so I always wonder what it looks like here. So we have the status up here, which is whatever status. Nothing. We have files, work trees, submodules. So we haven't really learned about work trees nor submodules. We just have files, no changes, right? Then we have local branches, which is our main. And we have, okay, so this is our basically git log, whatever we would call in git as log. This is being displayed here. For testing, we can see that this is the only difference, right? Everything all the way up to this cleanup here is what it was, but the main branch has the new added author. While testing, it sees everything before it up to cleanup and then its own bumped version. And alternate reality is totally unaware because it's stuck in the past. Okay, so we don't have, I guess, option here to display all or something. Okay. And remotes is we don't have any remotes. We didn't post it nowhere. We can list tags. Okay. So suddenly all those features here start making sense. And then we have commits for the thing. So we can inspect each commit, what changed, right? For the main, we added the author. There it is. Removed empty, added in the filled in one. For testing, notice that this didn't change. What the hell? So if we're here, why doesn't this change? Why doesn't this update? Okay, I did not expect that. We have reflog, whatever that is. Oh, wow, this is like more detail. Moving from testing to main, from main to testing, and back and forth. So basically Git is actually recording all those things that we're doing. Interesting. But for some reason, no matter, can I double click? Whoa. Oh, I double clicked and I saw stuff. How do I go back? Escape. Okay. All right. Still don't know how to use it exactly when we have stat. Okay. All right. Let's get back to normal. I was just curious. But okay, a lot of that stuff that we're learning translates directly there, so that's cool. So, yeah, exactly. This one line decorate graph all will print out the history of your commits showing where your branch pointers and whatnot are. So we basically saw that our head of the is on the master, right? Our testing point, the head doesn't point at testing anymore, but we have the divergence and whatnot. Because a branch in Git is actually a simple file that contains the 40-character SHA-1 checksum of the commit it points to, branches are cheap to create and destroy. Creating a new branch is as simple as writing 41 bytes to a file, 40 characters and a new line. And that's it, right? So that's pretty much free. This is in sharp contrast to the way most older VCS's tools branch, which involves copying all of the project's files into second directory. Yeah, I remember at some point wanting to like branch an SVN or something in a larger project, and I was like, oh, don't do that. It's gonna pretty much crash the server. This can take several seconds to even minutes, depending on the size of the project, whereas in Git, the process is always instantaneous. So for example, in game development, if you were to create a branch by copying files, that would often mean that you actually need to copy terabytes of data just so that you can create a branch. Here, we just create a file that has 41 bytes and that's it. So yeah, that's a nice difference. Also, because we're recording the parents when we commit, finding a proper merge base for merging is automatically done for us, and it generally is very easy to do. These features help encourage developers to create and use branches often. So we got a few new words here that are not really explained yet. Because we're recording the parents when we commit, right? That's fine. Each commit points at its parent. Finding a proper merge base. So we have the idea of the merge and a base. So I guess the idea here is that, the one of graph. Because we split here, if we want to kind of combine changes of maybe we change the version and added author, and we want to merge them together back into having just the main branch, that would mean that we're merging, right? And the base, as far as I understand, it will be the point where we actually split into two separate branches. So that's our base. That's, I guess, the starting point, right? To see what changed since then here and what changed since then there, to figure out what actually is being merged. Okay, so all that is automatically done for us. So all this feature encourages developers to create and use branches often. Exactly. Let's see why you should do so. So creating a new branch and switching to it at the same time. It's typical to create a new branch and want to switch to that new branch at the same time. This can be done in one operation with git checkout -b new branch name. So that's basically, instead of checking out to an existing branch, we just add -b and I guess create a new branch name, and that's a shortcut. It's just weird that we need to do it through checkout, huh? I guess that's why they changed it. I heard that git switch is a new thing, right? Oh, and there we go. Again, it's right after that. From Git version 2.23 onwards, you can use git switch instead of git checkout to switch to an existing branch. So we do git switch and testing branch, okay? So let's say git switch testing. There we go. That's it. Awesome. Create a new branch and switch to it. Git switch -c new branch. So the C flag stands for create. You can also use the full flag create. Okay, so I like that way more, because suddenly we have one command to keep switching between branches, and we can optionally create it instead of doing the one creation with branch and one creation with the checkout command. Weird, right? Here is all in one. So we're on testing. Let's do git switch -c, and it'll be testing v2, right? Bam. Switch to the new branch, testing v2. So if we're gonna do our graph now, we can see that this commit is pointed at the head, which is testing v2, and the testing branch, right? So we kind of have more. And return to your previously checked out branch. Ooh, git switch dash. Oh, that's nice. Git switch, and dash is just for the last. So we'll get us back to testing. We do git switch to main, right? And then we're gonna go to git switch to testing v2. And now we can switch between them. Just git switch dash back to main, back to testing, back to main, back to testing. I like how fast that is. And just goes, right? Okay. So we're back on main. Okay, well, that was a somewhat decent explanation. Still kind of cryptic, but sure. So let's go to the next one. Git branching, basic branching, and merging. Oh, so we're getting into the more scary territory, which is merging. So let's go through a simple example of branching and merging with a workflow that you might use in the real world. You'll follow these steps. Do some work on a website, create a branch for a new user story you're working on, do some work on that branch. At this stage, you'll receive a call that another issue is critical and you need a hotfix. You'll do the following. You switch to your production branch, create a branch to add the hotfix. After it's tested, merge the hotfix branch and push to production, switch back to your original user story and continue working. Exactly. So it's often that you actually want to switch around between things. Well, let's say I'm waiting on something here or something is urgent. You might often have like separate branches for separate things you're working on. So basic branching. First, let's say you're working on your project and have a couple of commits already in the master branch, right? We have commit 0, 1, and 2, and this is our master branch. Okay. You've decided that you're going to work on issue number 53 in whatever issue tracking system your company uses. To create a new branch and switch to it at the same time, you can use the git checkout command with the B. In our case, we would do git switch -c and issue 53. Switch to the new branch. And this is the shorthand for it, for first creating the branch and then checking it out. Okay. All right. Perfect. We basically added a new branch, which is just a pointer. You work on your website and do some commits. Doing so moves the issue 53 branch forward because you have it checked out. That is, your head is pointing to it. All right, so we add a new commit, so the issue is here and head points at issue 53. Now you get a call that there is an issue with the website and you need to fix it immediately. With Git, you don't have to deploy your fix along with the issue 53 changes you've made. And you don't have to put a lot of effort into reverting those changes before you can work on applying your fix to what is in production and whatnot. All you have to do is switch back to your master branch. So, however, before you do that, note that if your working directory or staging area has uncommitted changes that conflict with the branch you're checking out, so we already checked out what that conflict means, Git won't let you switch branches. It's best to have a clean working state when you switch branches. There are ways to get around this, namely stashing and commit amending. That we'll cover later on. I never actually thought about using commit amending for that very purpose. I wonder, it would be nice to learn a little bit more about this commit amending. Looks like we'll learn in the stashing and cleaning branch, whatever chapter. But how do you, let's say I pushed a bunch of changes to like a commit. I guess I could extract them out of there when amending. Interesting. For now, let's assume you've committed all your changes so you can switch back to your master branch, right? Git switch to master. At this point, your project working directory is exactly the way it was before you started working on issue 53, and you can concentrate on your hotfix. This is an important point to remember. When you switch branches, Git resets your working directory to look like it did the last time you committed on that branch. It adds, removes, and modifies files automatically to make sure your working copy is what the branch looked like on your last commit to it. So next you have a hotfix to make. Excuse me. Let's create a hotfix branch on which to work until it's completed. Let's create a hotfix branch on which to work until it's completed. So git switch-c hotfix. I'm already translating to the switch command. And then we added the index.html to do the hotfix, right? We committed .change with a message fix broken email address. And that was added. Great. So we can see that our changes that the issue 53 is pointing to are existing here, while our hotfix is existing here. And they are both pointing at the last master commit as a parent, right? You can run your tests, make sure the hotfix is what you want, and finally merge the hotfix branch back into master branch to deploy to production. You do so with the git merge command. Okay, so we have a new command, finally, git merge. So first we switch to master, and then we say, hey, git merge hotfix. Okay, so it sounds like the git merge will merge some other branch that you're pointing to with a name here into the branch you're on right now. So it does this, set fast forward, and some changes, right? You'll notice the phrase fast forward in that merge, because the commit C4 pointed to by the branch hotfix you merge in was directly ahead of the commit C2 you're on. Git simply moves the pointer forward. To phrase that another way, when you try to merge one commit with a commit that can be reached by following the first commit's history, Git simplifies things by moving the pointer forward because there is no divergent work to merge together. This is called fast forward. Exactly. So when we have this here and we say, hey, I'm here on C2, I want to merge in hotfix. It sees that, oh, from here, there's only one path here. There's no divergencies. There's nothing else that, there was no way to go forward from C2 to the hotfix or somewhere else. It's just direct reach. It's, hey, I'm going to move this into here and we're done. We don't need to even try to pretend that we merged something. Your change is now in a snapshot of the commit pointed to by the master branch, and you can deploy the fix. All right, so it literally moves the master pointer for the branch to point at C4 and nothing else. There's no extra actual merging, no extra objects created. It just that. It got moved, pointed at a different thing. Great. After your super important fix is deployed, you're ready to switch back to the work you were doing before you were interrupted. However, first you delete the hotfix branch because you no longer need it. The master branch points at the same place. You can delete it with the D option to git branch. So git branch delete hotfix. So in our case, if we're gonna go with all of the branches, we don't need the alternate reality branch. So I can probably do git branch delete alternate reality. Error, the branch alternate reality is not fully merged. If you are sure you want to delete it, run git branch capital D alternate reality. Okay, so I guess this is because in alternate reality we actually made changes. Therefore, they are diverged here because we actually had a commit that when really merged in. So just for our safety, it says like, oh, you know what, this is not like up to date, so you might not want to do that. In our case, we want to, so let's change it to capital D to like really delete it. And okay, delete it. So what it looks like now. Okay, it just straight up doesn't exist anymore. Something tells me that commit still exists. We just deleted the branch. We don't point at it anymore, and therefore it doesn't show up. Wonder how to remove that commit stuff too, to actually clean it up. But we'll learn. Okay, but here they were able to use the git branch D, just to normally delete the hotfix because it's basically the same. It's already merged in. So now you can switch back to your work in progress branch on issue 53 and continue working on it. So git switch to issue 53, and we can edit our index, do some commits, right? More changes. There we go. Even though we made this hotfix here, you can see how they are already diverged completely. And yep, we're in here now. So notice that he edited here index.html, the same thing that was edited for the C4. So the same file is modified here as well as here as compared to the C2, right? Because the modification happened here and here. So really these two are both different than C2. It's worth noting here that the work you did on your hotfix branch is not contained in the files in your issue 53 branch, right? It's separate. If you need if you need to pull it in, you can merge your master branch into your issue 53 branch by running git merge master. Or you can wait to integrate those changes until you decide to pull the issue 53 branch back to master later. Okay, so there we go. It's a common practice that if you're working on something for a longer time and you have your branch, from time to time, as you see changes being made to master or whatnot, you just pull those changes in so that you're reducing how much diverged you are in from the master branch, so that you're still working on somewhat up-to-date code, even though you're in a separate branch. And this way you can kind of avoid conflicts in the future, because you're gonna break your branch and your code that you fix it here, rather than trying to merge them in and having those big problems here. Maybe you made some modification, merge it in, and you risk basically having conflict on main branch, which often is supposed to be the single one that always works. So yeah, you just pull into your branch often. So in our case would be where I'm going to get switch to testing, right? And what was the status? One line. Let's just go here. I'll get log, one line graph, right? We are in our head is in testing with bound version, right? So in theory, I could try to merge that main into my branch with the added author, but those files are actually changed. As in, there was a change to the file I had changed here, so I actually might have conflict. Let's see what happens. Git merge, and I'll say main. Because I'm on the branch testing, that means I want to merge main into testing. Auto merging package JSON, conflict, content, merge conflict in package JSON, automatic merge failed, fix conflict, and then commit result. So when we look at our status, whoa, we have new letter, U. I guess U means conflicts. Look at that. So I guess we'll learn about it right down here. Oops. And Adarasha says, hey, how are you? How are you doing? So basic merging. Suppose you decided that your issue 53 work is complete and ready to be merged into your master branch. In order to do that, you'll merge your issue 53 branch into master, much like you merged your hotfix branch earlier. All you have to do is check out the branch you wish to merge into and then run the git merge command. Okay, so we finally have the first explicit information that you need to check out the branch you want to merge into and then call the git merge command. So git checkout, switch to branch master, git merge this, merge made by the recursive strategy, bam. Okay, this looks a bit different than a hotfix merge you did earlier. In this case, your development history has diverged from some older point. Because the commit on the branch you're on isn't a direct ancestor of the branch you're merged in, Git has to do some work. In this case, Git does a simple three-way merge using the two snapshots pointed to by the branch tips and a common ancestor of the two. Okay, so it figured out that if I was here on issue 53, I mean, we switched to the master, which was here. But as far as I know, through this hotfix, the index.html changed here. And this one also had to change to index.html. And therefore, when we tried to match this one here, we basically went backwards and found like, oh, this is the common ancestor of both of those. So, yep, that's it. Back when they both diverged. Instead of just moving the branch pointer forward, Git creates a new snapshot that results from this three-way merge and automatically creates a new commit that points to it. This is referred to as a merge commit and is special in that it has more than one parent. Okay. Adarasha says bye. goodbye. So there we go. We got a new branch here. Master points at it, and this branch points basically at C4 as a parent and the C5 as a parent, right? So this is our first situation where we actually have two parents of a commit. Now that your work is merged in, you have no further need for the issue 53 branch. You can close the issue in your issue tracking system and delete the branch. So git branch, delete issue 53. Okay, so we're gonna do that after we go through basic merge conflicts because that's what we did here, right? Occasionally, this process doesn't go smoothly. If you change the same part of the same file differently in the two branches you're merging, Git won't be able to merge them cleanly. If your fix for issue 53 modified the same part of a same file as the hotfix branch, you'll get a merge conflict that looks something like this. So we tried to merge the issue 53 into master and auto merging index HTML conflict content. Merge conflict in index HTML, automatic merge fail, fix conflict, and then commit result. So we have pretty much the same thing. So basically it tells us that it tried to automatically merge those changes to both changes to the same file, but because it was roughly the same area, it just says like, nope, I am not sure if what I'm going to result with is correct. So Git hasn't automatically created a new merge commit. It has paused the process while you resolve the conflict. If you want to see which files are unmerged, oh, so U is unmerged. Oh, right, because we have this gigantic U. This is unmerged. At any point after a merge conflict, you can run git status. All right. So we can see unmerged paths, both modified, bam. Use git add file to mark resolution. Oh, so we can resolve it by just adding it after, I guess, editing, right? Anything that has merge conflicts and hasn't been resolved is listed as unmerged. Git adds standard conflict resolution markers to the files that have conflicts, so you can open them manually and resolve those conflicts. Your file contains a section that looks something like this. We have this thing, head index HTML. We have our content here, big divider, and more content, and the end. So this means the version in head, as in your master branch, the one that we have checked out. Okay, finally I know what a head means, so that makes sense now, because that was what you had checked out when you ran your merge command. So it's the top part of that block, everything above the bunch of equal signs. While the version in your issue 53 branch looks like everything in the bottom part, in order to resolve the conflict, you have to either choose one side or the other to merge the content yourself. For instance, you might resolve this conflict by replacing the entire block with this. Like, okay, this is what we want, right? Because this one got the ID footer and contact is this, while this one has ID footer and completely different message, right? And it's maybe split into those 3 lines. And because this and that looks vastly different, we don't know. Maybe we want to keep up both changes, right? We still have the split, but we have updated email address. This resolution has a little of each section, and whatever those repeat symbol lines have been completely removed. After you resolved each of these sections and each conflicted file, run the git add to each file to mark it as resolved. Staging the file marks it as resolved in Git. So let's do that. And additionally, if you want to use graphical tool to resolve these issues, you can run git merge tool, which fires up an appropriate visual merge tool and walks you through the conflicts. So let's see that, because I could just edit in NeoVim, right? NeoVim, package JSON, and we can see, oh, there we go. We have those, this very issue in here. So looks like the version Git was able to automatically figure out, okay, this changed only one file, so I'm gonna keep the version 2 and that's it. But in here, we have a little bit different situation. Because in our main branch, we have no author and license MIT. Okay, because these are lines right next to each other. while on the testing branch, we have the author and a different license, right? So what we should do here? Well, we want to have the author of this. I don't remember how to move it. There we go. So we're gonna move it here. We're gonna remove this one and this one. And we want the MIT license. So I just removed a few lines. And this is basically what I want the file to look like. But I'm gonna quit and not save it, right? We still have the status of unresolved stuff. So I want to try out that, what was it? Git merge tool. Git merge tool. And this message is displayed because merge.tool is not configured. See merge tool help for help configure it. Okay, so we basically don't have anything installed right now. Looks like we could have opendiff, kdiff, 3, bunch of those, meld, tortoise merge, diffuse, perforce merge, smurge, and emerge. So many of them. Yeah. So we would need to have one of those. I guess I don't have them installed. So what's going to happen if I'm going to do this? Does it just copy it? Nope, not in this one. Whoa. So a bunch of text. Git merge may be set to one of the, so git merge -- tool equals and whatnot. We can set one of those, and there's even more here than we saw before. Some of the tools listed above only work in a window environment. If run with terminal only session, they will fail. So how about we just ask AI what it suggests that we could use? All right, let's just move it here maybe, and we're gonna do, let's actually copy this whole thing. See what happens. Let's copy this thing. And which of the following tools is modern, easy to use, yet powerful, and works well on Arch Linux? I'd prefer if it was a terminal-based tool. And we're gonna simply put in all this stuff in here. And let's see what our Claude Opus will, let's actually give it some more thinking power. Wow, this all got rearranged. Let's see what happens. Because to be honest, I have no idea about those tools. Some of them kind of sound familiar, like, Beyond Compare and whatnot, but that's like, I believe, paid product and a bunch of other stuff. So based on your available options and requirements for a terminal-based tool for Arch Linux, NeoVim Diff is your best choice. Okay, it's the most modern and powerful terminal-based option in your list. So NeoVim Diff 2. Oh, so this is different than that. For merge conflicts, I'd specifically recommend NeoVim Diff 2 as it provides the standard 3-pane layout, local merge and remote that most developers find intuitive. Okay, so git config, global merge tool, NeoVim Diff 2. We can actually set it. We have variants. We have this one, custom layout. 1 is 2-pane, 2 is 3-pane, and 3 is single pane, merged only for simple conflicts. Okay. And alternatives, Difftastic, modern syntax aware. Ooh, syntax aware diff tool that can be integrated with Git. Ooh, Difftastic. We're gonna check that out. Anything else? So NeoVim Diff, we basically jump between conflicts with bracket C. Okay. DO is obtain, pull from the other pane. DP is push to the other pane. Diff update, refresh diff highlighting. Okay, so let's look at NeoVim Diff 2 if we can find it in the browser or something. That would be fun to learn a little bit. NeoVim Diff 2. So we have NeoVim IO user for diffs. Okay, that doesn't say much. Huh. I don't think we're gonna get screenshots. So it sounds like it's specifically a NeoVim tool, right? Using NeoVim as merge tool. We have div view and other using git default NeoVim diff. All right. Bam. Usage, and then we have a bunch of other stuff. Okay, so that's option 1, and option 2 was to use, what was it, Difftastic or something? Difftastic. Structural diff that understands syntax. Oh, I really like structural diffs. They are awesome. So what do we have here? We actually have some visual example for a change. So basic example, diff-t, this file and that file, and we have basically one pane, the other pane. So I guess red is what was removed, this is what was added, and understands nesting and whatnot, understands which line should be aligned or whatnot. So 1-minute demo. Look at that. Okay, straight up closure, why not? You can see that this was removed, this was added, right? Has support for Git 2. Let's look at some recent commits. Okay. Because this one literally just printed it out. But how do you use it to actually edit stuff? So, okay, so this would be used in our Git, I guess. And printed out. Interesting. So that would be like a default diff tool. But what about actual resolving conflicts? So yeah, it goes that, and nothing about conflict resolution. So that might not be it. That's different. So what the hell is the chat saying? If you want something even more powerful, install Difftastic, a modern syntax or diff tool that can be integrated with Git. For merge tool specifically though, NeoVim diff remains the best. Okay, so it just says, okay, this is just for displaying diffs, not for actual merges. Okay, so let's try to do that. We're gonna make NeoVim diff 2 as our default merge tool. So let's try that, all right? We're gonna paste this and let's see what happens. We do merge tool. Oh, look at that. Beautiful. I forgot how to make it full screen like this. Yeah, there we go. How do I navigate here? Because we have 1, 2, 3, 4 files open, looks like. A little bit confusing. Which one is which one? JK, and I can move and it highlights the same thing, the same line in various areas, right? So right now I'm on the main branch. Therefore, I would expect I guess the author to be set. Yeah, exactly, because this one shows head. Oh, so this is what I have locally, right? This is one of, maybe this is the base, the common ancestor or something. Which one is which one? Okay, I start getting confused. And again, we don't have options to go left, right. Do I switch somehow? Okay, with control, I can move between the, okay, so it shows me that on the left is local. This one is the package.json, which is the actually, I guess, totally local. And on the right is the base. So I guess on the right is what was on this branch. as a common ancestor, or not really. There's no common ancestor being displayed here at all. Because common ancestor had 001, had nothing in as the author, and license was ISC. So this is, none of them is that branch. 02 is, I guess, local 525. I don't even know. Doesn't. Too bad it doesn't display which branch you're really on. But I guess this one is from the testing branch, right? Because we updated the version and we changed the license. While the one on the right is from the main branch, where we basically had the version unchanged, but we changed the author. So how does it help me actually making any changes? Do I just delete stuff here? I guess. Oops. I guess I just resolve the conflict. Can I just do write and quit? Quit all? Okay. We have package.json original. What the hell is going on? So I guess the original is the track before the merge. I am so confused. So that's before the config resolution. Okay. Oh, and package.json already put itself in staging. So I guess that's what it was, because we ran the merge tool and we saved the file that automatically marked it as resolved, I guess. And because of that, we have this automatically staged by the merge tool. Okay, all right. I assume that's how it works, but again, it's not very well explained. So let's just see what's in here. So we have git merge tool, this message displayed, so the same thing. If you want to use a merge tool other than the default, Git chose opendiff in this case because the command was run on macOS. You can see all the supported tools listed at the top after one of the following tools. Just type the name of the tool you'd rather use, right? If you need more advanced tools for resolving tricky merge conflicts, we cover more merging in the advanced merging. Okay. After you exit the merge tool, Git asks if the merge was successful. If you tell the script that it was, it stages the file to mark it as resolved for you. You can run git status again to verify that conflicts have been resolved, right? And it's just modified. If you're happy with that and you verify that everything that had conflicts has been staged, you can type git commit to finalize the merge commit. The commit message by default looks something like this. Merge branch this into that. So it sounds like if I'm gonna do git status, like normal status, says on branch testing. Wait, we're on branch testing now? Oh yeah, because we're merging main into testing. I forgot. We were pulling the changes in. All conflicts fixed, but you are still merging. Okay, so somehow Git tracks that we are still in the process of merging. I use git commit to conclude merge. Changes to be committed is this package.json that we modified, and we have some untracked files. And I wonder what happens, because I wonder if it's the git merge, the merge tool from NeoVim that actually created this file, because this wasn't there when we were kind of doing it manually, editing the file. So I'm curious. So let's do git commit. And we say merge branch main into testing, and it just mentions what conflicts there were. Committing a merge, blah, blah. Yeah, okay. Write and quit. So git status. We are no longer in any kind of merge conflict. We're not during a merge. We're git what was it? Log. Sure, all one line graph. Look at that. we're here. Still the branch testing. And yeah, it looks like we merged main into our testing branch. Beautiful. Yep, so that's it. We can basically remove the package JSON original because we don't want that. All right. So this way we have more up-to-date file here, and therefore we could, in theory, do edit the package JSON again and maybe bump the version to something like version 3. Why not? And git add package JSON. There we go. Git commit message bumped version again. Bam. Our git log should look in a way that this is where our merge happened, right? We went from our main, we put it into our testing, and our testing branch points at this new bumped version again. So that's that. This is like the end of this chapter, right? With the stuff. If you think it will be helpful to others looking at this merge in the future, you can modify this comment message with details about how you resolve the merge and whatnot. Okay, so that was our chance where we're merging. So now let's, because notice that we're not on main. Even though this looks merged in, the main still exists here. We just merged the changes from main into our testing branch, modified it further. So in theory, if we were to switch to main now and try to merge the testing into main, it should be like, hey, there's conflict, right? Because this one set it to 0.02 while this one is setting it to 0.03. Well, someone tells me that because we merged it here, there isn't, like, you know, when we want to try to merge in here, we don't have any divergence anymore because this one was in here, so they kind of point, those pointers kind of help out. So let's try that. So let's do git switch to main, and we do git merge testing. And what's going to happen? Fast forward, there we go. Nothing, just package JSON changed. So we merge it in, git log, oops. And look at that. Now the main is pointing here as well. It just moved from here to here. Nothing crazy happened. We just fast forwarded, right? So no need to show any splits or anything. It's very interesting how it works. It's kind of unintuitive from the graph perspective because you would expect that, oh, this merge happens somewhere here. But in theory, you merge those two branches here. So from like being optimized, there's no point to like kind of do it again. We already have it done. Okay. That's great. And yeah, we have them both here. So I can do git branch delete with a lowercase testing. And there we go. We deleted it. We don't need to worry about it anymore. It just doesn't exist. We could probably also do the same with testing v2. There we go. And we have nice and clean everything. The only thing is that we still have that history that there was some kind of divergence here, which, you know, some people like to have it there in the history, some people don't. But I guess we'll get to that in the future. So that's that. And I think that will be enough for today. We have some kind of grasp on basic branching, switching between them. We went through merging without conflicts and with conflicts. Even we figured out the merge tool or whatnot. And I feel like I'm getting a little bit more comfortable with doing it from the command line. It's still hard to read compared to some, you know, visual versions, but I think it's good enough, yeah. And next will be branch management. I guess will be literally, okay, let's list them, let's do stuff. Probably will be something about cleaning them up and whatnot. But we'll save that for another time, all right? So I will thank everyone for watching. It's always fun to share what I'm learning. I hope that whoever's watching that had a chance to learn something as well. And see you next time.